Welcome back. Today we are going to see about MongoDB pagination and its sorting. So we can go to the concept. Pagination is an application level concept. MongoDB does not manage concepts like page 1, page 2, next page, previous page. So pagination is something like that. It is not MongoDB supports externally. It supports some features using that in application when we develop, we can do the pagination concepts. So the application decides how pagination works and uses MongoDB's query features to implement it. MongoDB provides the building blocks to sort the one, skip, and limit. And range queries such as greater than last seen. Greater than is our logical operator, last seen ID. We'll see very detailed what it is. So offset pagination. Offset pagination is nothing but using of skip and limit. So if application wants a page 3 pages with a size of 20, so how it if then there is totally how many entries are there? 60 entries are there in the 60 documents are there in the MongoDB. So 60 documents means it calculates skip page minus 1 into size or so page number minus 1 into the size is the formula. So whenever it calculates for each page, then it calculates that find this. It is minus id short means it's ascending order, descending order. We will see how the short functionality in upcoming slides. Short, skip 40. You want to skip first 40 and then have the remaining thing. And limit 20 has the only last 20. That is the formula here, the formula used. So this is the output. It will give it skip first to 40 and then limit only the 20. Okay. So the problem with the large data set, for example, if now only to skip 40 means the entry should go one by one to the 40th set. Now think there are millions of record. If you want to skip here, MongoDB to advance through a large number of entries before running the requested 20. For this 20, it want to skip these many records, it wants to pass through it. So it is not good solution when it comes with the large data sets. That's what people preferring for large data set, keyset and cursor pagination. So instead of skipping to this record, as I'm going to the pagination, I'm going to have the application wants to keep the record of the last record. Says give me the last record gives me the records after the last record. So application wants to store the last scene ID. Then greater than the last scene ID means it will populate after this ID, short by the ID and limit 20. So it doesn't want to skip one by one 20 20 again and again. It just give me the last scene ID, then it was very easier to progress the other data. That is the main advantage. How pagination works, for example, the request for no cursor limit equal to 5. It will give first 5. Okay, application returns data 1, 2, 3, 4, 5. The next cursor 105. So application stores the 105. So when it wants the next one, it will see the last scene ID to from this to this. So it will very easier for the last data sets. The next record using the 104. See here, I need the cursor is at 105, the limit 5. So I can say greater than 105, limit 5. So MongoDB returns the next 10. So the next cursor will be 110. So this is the way the application needs to be designed. So it will be the pagination will be good for the large data sets. So there are some uses table start. We will see this table start in the upcoming slide. Creating a matching index, we'll also see that. MongoDB has an internal database cursor, but that is different from the API cursor used for Keyset Pagination. This cursor is different. The cursor concept in the MongoDB is different. Don't get confused. That is the main note here. Yeah. The next one is cursor pagination which we explained are the same thing. The first request is 5 and it goes with the last scene ID will be stored. So we'll get 105 is the same. Okay. The next one is what is sorting? The sorting is arranges the document in the result set based on the value one or more field. By default, Mongo if we are not seeing any sorting method, it's sort by the ID in ascending order if no sort is specified. If sort is specified, if the 1 or minus 1, 1 means ascending order, A to Z 0 to 9, minus 1 is descending order. So in the reverse. So which field you want to sort, you can give 1 or minus 1 to that field. So it will sort based on that. Okay. You can sort by single field. Sort name 1 means it will sort in ascending order. If sort age minus 1 means sort descending order. Okay. If multiple fields means age and name. So how the criteria will give is first by age, high to low. After in the age, if there is two ages has the same age, then sort the name by ascending order. This is the concept here when you have the multiple fields. Okay. This is very important. When two fields are there, how it will sort. Okay. And sorting by date, created it. This is always very, like then the table sorting, we will, this concept is very important. Okay. So stable sorting is important. For cursor pagination, use deterministic sort to ensure consistent and reliable results. So when it comes for the cursor pagination, this stable sorting is very useful. What is stable sorting? Mostly it's saying sort based on the unique identifier and the created one. This is a very ID that acts as a unique tiebreaker when multiple documents have same createdAt. So they are saying stable sorting is using createdAt, but there are circumstances when two documents can be created at the same time. So at that time, using ID is a very important thing. Creating matching index. A matching index improves performance for shortcut queries and pagination. Always create an index that matches your sorted order for performance. Okay. Offset versus cursor pagination. MongoDB skip plus limit, range query plus limit. So range query is nothing but the last seen ID plus the limit. Large data set less efficient. It is less efficient because you want to pass through a lot of data. Better suited. Page numbers, it will be easy because you are going to the specific page numbers, not natural. Next and load more, both are excellent. Infinite scrolling, if you want to scroll, some users used to scroll often. For both, it is good and it is excellent. Implementation, this is very simple. It is little complex, not complex because you want to store the last seen ID internally. You want to always have the track of it. So mainly when the data set is very high, the large data set use keyset plus cursor. When the data set is very limit, skip this limit is very useful. That is the conclusion here. Yeah, this is about pagination and sorting. If you have any queries, please let me know. Thank you. For any queries, I can ask in the comment.